So our last process is agglomeration. And it's a process relevant for pellets plants mostly. But this slide shows 3 machines that work under different principles to produce similar materials. So for this machine, it is possible to measure the agglomeration rate with time, which in turn allows to estimate how long the process will take. It is also important to test what is the maximum amount of material that can be used per batch, and to test the strength of the pellets to ensure that they won't crumble during transportation and handling. So here we see an example of a briquetting machine simulating EDEM. Although this example shows a very simplified geometry, it actually allows to import very complex CAD model for analysis. So the material coming in at the top get pressed by the 2 roller sections, forming a block of materials, and the briquetted fall onto a conveyor belt and are then taken away. So the potential analysis for this kind of equipment will be measuring the minimum compressive force required for pelletization, also testing how much agglomerant is needed for effective agglomeration, also testing the strength of the pellets, and identifying the maximum feed allowed that will help to optimize the pellet production. So here in this slide, we can see the analysis. We can evaluate the compressive forces in between the 2 wheels to ensure the machine can endure great forces, but also pressures. So in addition, coloring the pellets by compressive forces provides useful insight into the quality of the pellet. So we can see in this video, the particles don't seem to be compressed uniformly, even though their shape is fine when hitting the conveyor belt. So a close-up of a pellet during the moment of maximum compression shows that the top half of the pellet get compressed much more than the bottom half. And this could result in the crumbling of the bottom half, as we can see in the image at the bottom. And that will basically result in the effective pellets.